And this is actually an existing building in the UK. It's not that high, it's about 100 meters. So we did this simulation for a specific reason, is that this building is infamous, I would say, in the UK. Somehow, so the wind hits the building, then it's pressed downwards, and around the corner it's accelerated, so the wind velocity is multiplied with up to 6 times. And you can see the turbulence, that's the entrance, so it's very hard to actually go into the building. They actually hired rugby players to help people cross the street, and this is true. So it's a quite funny story, but the fun part ended when a person actually was tragically killed, when the wind accelerated up to 100 kilometers per hour and turned the truck over him. And they were forced to build mitigating structures to stop the wind, the effect of the wind. And they lost millions of pounds, and they lost the property value goes down when people avoid the area, when the retailers there lose money because people don't want to sit there in the restaurants or go to the shops there. So it's a huge problem. So there is a number of CFD softwares out there today, but the problem with those is that they were developed during the 80s, designed to fit the supercomputing power of that time. And in the mid-80s, the computing power of the best supercomputers was equivalent to an iPhone 4. So what they needed to do at that point was to do a lot of trade-offs, unreliable modeling, a lot of manual work in order to take care of these computations, because believe me, fluid flow simulations is among the most complex and hardest thing to do. Its turbulence is chaotic, so it requires a lot of computational power. And today, if you want to do a simulation, you need typically years of experience, and it can take weeks to do just one simulation if you're unlucky. And if you ask like 3 engineers to do a simulation, you will get 4 different results, and each one is correct. So that's about how it is, but we will change that with Ingrid Cloud.